Falling particle receivers are an emerging technology currently being developed by the renewable energy sector. In principle, they consist of multiple vertically integrated components which drop particles through the system to be heated by concentrated solar energy. Australia has a great potential for solar energy applications, and while many exist, falling particle receivers are expected to operate more efficiently and bypass typical issues. However, one challenge which limits the operating efficiency is the effect of wind on the system, which disturbs and ejects the particles as they fall. This project investigated this challenge by designing and building a falling particle receiver prototype to study the aerodynamic effects on particles. The project consisted of 4 primary stages. The first stage consisted of the design process, which was undertaken by researching and integrating the operational requirements of existing systems into the prototype design. This would ensure a relevant prototype model. Particle flow behavior was then investigated experimentally to confirm design optimization. This was done by creating and testing a scale hopper prototype to ensure the required conditions could be met in the final design. The second stage consisted of the build phase. This process involved close collaboration with technicians in the manufacturing process and setup of the rig at the Theberton laboratories. The third stage involved characterization and alteration of the imposed flow conditions to ensure the required aerodynamic conditions were met. A large axial fan and settling chamber was used. In the testing phase, the design requirements were confirmed. After this, particle fall and ejection patterns in tandem with control volume flows were investigated in comparison to aerodynamic characteristics, which were altered using flow speeds, receiver volume, and receiver discharge areas. This found that smaller flow speeds, discharge areas, and receiver volumes resulted in lower ejection amounts and more stable patterns. These particular observations are able to help give insight and mitigate the effects of wind on real-life systems. Thank you.